So continuing to use our properties of logarithms, and this will be really helpful to us when we're solving, we can condense two logarithms or more down into a single logarithm. So in calculus, it's helpful for us to spread them out and write them as lots of little logarithms, expand the expression. And in this situation, we're going to condense it. So when I see two logarithms of the same base and they have a minus in between them, I can write that using the quotient rule. So this becomes the logarithm of x squared minus 25 over x minus 5. All right, so I've condensed it. I've written it as a single logarithm. And of course, this is helpful because if I notice that numerator is a difference of squares, and that allows me to factor this. So if I factor the numerator, I would get x plus 5, x minus 5, divided by x minus 5. And now we can see I have an x minus 5 in my numerator, also in my denominator, and this can simplify to the log of x plus 5. Of course, we know in this situation that my x value cannot equal 5 because that was originally in the denominator. Okay? So my final answer here is this basic logarithm, which is easier for us to deal with than that larger two-termed expression. So let's do another example. Three, the natural log of x minus 1/2 the natural log of x squared. So again, we have a minus between these two logarithms, and we can condense them. However, our property says that if we have 1 log minus 1 log, all right, our quotient property of logarithms says log base b of m minus log base b of n equals log base b of m over n. And so pay special attention, both of those logarithms have an invisible 1 in front of them. In order for me to use that property, I'm going to need to use my power property first. So this is the same as natural log x cubed minus the natural log of x squared to the 1/2. Okay, so that cube went up and the 1/2 went up, both into the exponent of the argument. So when we square, when we have something squared raised to the 1/2 power to a power, we're going to multiply, and 2 times 1/2 is just 1. So now that I have a single logarithm minus a single logarithm, I can condense this, and this gives me the natural log of x cubed over x. And that argument, of course, reduces. I have the natural log of x squared, which is now a single logarithm. So we're going to stop there. This is equal to 2 natural log of x, but the directions said express as a single logarithm. So I don't want that 2 in the front. And I'll just add one more example here, making sure we can deal with our product rule. So again, we want to express this as a single logarithm. So I might have log base 2 of x plus log base 2 of x minus 3. And because I have a plus sign in between these two individual logarithms, I have 1 and 1, I can use my product rule. And so this is the same as writing log base 2 of x times x minus 3, which is log base 2 of x squared minus 3x in my argument.